Modern enterprise architecture requires managing overlapping releases, emergency hotfixes, and multiple environments simultaneously. You are dealing with thousands of shifting variables, where a single syntax error in a configuration file can take an entire cluster offline. To manage this chaos, development teams usually rely on an intuitive solution. They map their Git branches directly to their physical environments. You create a dev branch for development, a QA branch for testing, and a prod branch for the live application. It makes logical sense on paper, but let's look at what actually happens. Say a developer is testing a new feature, and they update a configuration file inside the QA branch to point to a local testing database. This shows exactly where the logic fails. When deploying the release, merging the QA branch into the production branch causes the Git engine to execute as designed. It overwrites your real production database URL with the fake testing URL, crashing the system. After an outage like this, developers become hesitant to merge branches. They start making direct, isolated edits to QA and prod separately. Within weeks, your environments drift out of sync, meaning a successful test in QA no longer guarantees the same result in production. By relying on branches to separate your environments, you lose the single source of truth. Your team is flying blind, detached from the actual state of the infrastructure. To escape this trap, you have to split your architecture. You must separate your compiled binary artifacts from your text-based deployment configurations. First, you have the application repository. This holds your source code and builds the unchangeable application packages. Developers can use as many branches as they want here to write and test their code. We can see that distinction in this split-screen layout. On the left is the branching application repo. On the right is your GitOps repository, which stores only the configuration files. This repository follows one rule. It operates entirely on a single straight line, the main branch. By forcing all configuration data onto a single branch, that branch acts as a live ledger of exactly what is running on your servers at any given second. But if we eliminate environment branches, how do we keep the QA configuration separate from production? The answer is directories. Here you can see a standard file tree inside the GitOps repository. Distinct folders labeled QA and prod sit side by side, rooted on the exact same main branch. The promotion flow shifts from branch merges to file updates. To move a release from QA to production, you open a pull request to copy the updated text file from the QA folder and drop it into the prod folder. An automated synchronization engine, like Argo CD, constantly monitors these directories. When a file inside the prod folder changes, the engine detects the update and syncs that specific configuration directly to your server cluster. This directory-based model bypasses Git merge conflicts and eliminates environment drift, leading to predictable promotions. Now let's look at how this architecture handles a critical production failure that requires an immediate and flawless rollback. Traditionally, an engineer might log directly into a server to manually revert a file. In a strict GitOps setup, the synchronization engine will instantly overwrite those manual changes to match what is written in the Git repository. Watch this timeline. To fix the outage, you perform a git revert. By reverting a commit on the main branch, Git changes the text file back to its previous state. The sync engine sees the change and automatically downgrades the live servers. This mechanism never erases history. Instead, you maintain a chronological audit log documenting exactly when the system broke and when the team reverted it. Look at this list of environment prefixed tags. By applying labels like prod v1.2.0 to the main branch after every deployment, you create historical bookmarks that represent the entire state of your infrastructure at that moment. The core trade-off of modern deployment architecture is simple. To achieve a conflict-free and auditable pipeline, you must stop using Git's most famous feature, branches, to manage your environments.